I have to get, yeah,
And then you
I'm
can start
recording,
talking. Yep.
but I need a pen, right?
Yep.
So then I say, well,
Number one.
yeah, this one here, there's your answer here, and I could point it there
Yeah.
and there.
Yeah.
Okay, and then I can just stop. Don't. So then you're saying, so I have to go to the next slide, which is this one,
Yep.
and then bring this back up again.
Well, it would just keep going. If you minimize it,
Yeah.
like it's still recording right now. So it
Well,
would.
no, it isn't. I paused it.
Oh, you paused it? Okay.
Well,
Stop.
okay, guys. I'm gonna try to do the next unit, but now they're not letting me come into school after today, so I'm gonna have to try to figure out how to do it on my phone, and that's gonna be an interesting experiment, but we'll give it a shot. But for today, I'm gonna do we're gonna begin Unit 8. And I will post like a quiz or something for you for Chapter 7. You know, really, there's no way I can make you do it for a grade for a test, but, you know, you guys are mature and smart enough to know you need to know how to do that stuff. So I'll post a quiz later today or tomorrow over Chapter 7, what we just finished last week, and then hopefully you'll be able to do it. But for Unit 8, it's basically logarithms and exponentials. So I'll, you know, hopefully try to get you at least the bare minimums of what you need to know for next year, you know? All right, so what I'm gonna do is just start with mama, okay? So let's see here. I can get rid of that, go to another page here. So mama for exponential, we're doing exponentials. Growth and decay. So that's basically the main part of the beginning of Unit 8. We'll concentrate on growth today, but decay is the same thing, only going the other way. So it won't be a big deal. And you'll probably get this pretty well. So it really is y equals a times b to the x. That's mama. Okay? Just like all our other mamas. And the one I'll do for you is, I'll do just a very basic one so you guys can get the idea of what we're doing here. So we'll do y equals 2 times 3 to the x. So there's your a, there's your b, there's your x, and there's your y, right? So if you wanted to just kind of look at this, let's do a few points. Well, the domain is all real numbers. I can use any number I want in here because you can raise 3 to any number, positive, negative, 0, it doesn't matter. So let's put 0 in there. If I put 0 in for x, 3 to the 0 is 1, and 2 times 1 would equal 2. So when x is 0, y is 2. Right there. So what if I put 1 in there? Well, if I put 1 in there, right there, 3 to the 1 is 3 times 2, that'll give me 6. So at 1, I'm already up to 6. If I put 2 in there, that's 9, that'll be already up to 18. So at 2, I'm way up there already, way up there at 18. But I can also put negative numbers in there. For example, negative 1. If I put negative 1 in here, that's 3 to the negative 1, which of course is 1/3 times our 2 here. That would be 2/3. So when x is negative 1, y is 2/3. Notice, still positive. When x is negative 1, y is 2/3, maybe about there, yeah? What about when x is negative 2? Well, if I have 3 to the negative 2, that's 1/9 times the 2, that's 2/9. Notice, still positive, 2/9. So at negative 2, I'm at 2/9 down here. Well, it's going to be asymptotic here. I hope you can kind of see that already, how it's going to go asymptotic to the x-axis, because no matter how big of a negative number you put in there, this will just become 1 over some big number times 2. It'll get very close to 0 without getting there. So it's asymptotic. So all of these exponential growth functions simply look like that. And the growth factor, when the growth factor is more than 1, it's going to look like that. So that's basically exponential growth. Okay, so we could do other ones as well. And then they move the exact same way. So for example, watch this one. I think you'll probably see the same movements happen, you know. So let's do this one. Y equals 3 times 2 to the x. Okay, now watch. Minus 1 minus 4. Now those of you who've been staying on the ball, most of you have, you will see that negative 1 right there and that negative 4, we're gonna just concentrate on y equals 3 times 2 to the x. And then we'll move it 1 to the right and 4 down, just like before. So in this particular case, I'm gonna just plot some points. Since this number right here is bigger than 1, it's going to be a growth function. So I'm gonna put 0 in again. If I put 0 in for x, that's 2 to the 0, which is 1, I'd get 3. So 0, 3. You're going to see it's going to look like the other one. If I put 1 in there, I'll get 2, 6. Well, I'm at 6. If I put 3 in there, I'm going to be off my chart, see? Or if I put 2 in there, let's put 2 in. 2 times 2 is 4, that'll be 12. So at 2, I'm already up to 12, so just up there a bit. So let's put a couple of negatives in. What if I put negative 1 in? Put negative 1 in there, right? That's going to be 3 times 1 over 2, which is 3 over 2, which is 1.5. So at negative 1, I'm at 1.5 right here. You can see how it's going to look just like Mama, right? If I put negative 2 in there, that's 2 to the negative 2, which is 1 over 2 to the 2, which is 1 over 4 times the 3, that's 3/4. So at negative 2, I'm down here to 3/4. So you can see what's happening, right? If I put negative 3 in there, up here, that's 2 to the negative 3, which is 1 over 8 times that 3 that's out here. So that's 3/8. So it's getting smaller and smaller and smaller. You see that? So this would look kind of like, and then asymptotic along the x-axis again like that. However, just like the ones we did in chapter 7, guys, look. I just did this part, but now I'm going to take care of the -1 and the -4. So just like always, up here with the x, move it the opposite way. So I take each point I did, and I move it 1 to the right, and then 4, 1 to the right, and 4 down. That point moves there. 1 to the right, 1, 2, 1 to the right, 1, 2, 3, 4 down. This point, 1 to the right, 1, 2, 3, 4 down. This one, 1 to the right, 1, 2, 3, 4 down. So you can see that the graph's going to kind of go like this. It'll be asymptotic now. Instead of at the x-axis, it'll be asymptotic at -4. Sorry if that was a little messed up. But it'll be an asymptote here at -4 because I moved the whole graph down 4. So that's exponential growth, like coronavirus, you know, how it's growing exponentially. You'll see that happening, unfortunately, with cases this week, probably. Okay, so that's exponential growth. Exponential decay we'll do tomorrow. Hopefully, I'll be able to do it off my phone. Okay, but this is an interesting kind of a problem. I want to just show you why we want to do this, and it's kind of has to do with money and interest and all that. So let's say I'm going to talk about some money issues here. Let's say that you have $1,000, okay, $1,000, excuse me, and you're going to invest it, put it in something that gives you interest. And let's say that interest rate is 7%, let's just say. So you will see this written 1.07. That's my growth factor. It's growing by 7%. So after 1 year, I will have $1,070. In other words, 1,000 times 1.07. What happens to that now? Let's say I just let my investment roll. So the next year, I'm starting with $1,070, and I multiply that by 1.07, again, assuming I'm keeping the same interest rate, right? So what would that be? Well, I'm going to over here and get a calculator. And hopefully you guys can follow this. So this year, I'm going to have 1,070 times 1.07. And that's 1,144.90. $1,144.90. Now notice, the first year I only got $70 worth of interest. This year I got $74.90 worth of interest. See how that's $74.90 more than the end of this year? Why did I get more interest the second year than I did the first? I'll let you chew on that for a second. Well, hopefully you can see that I'm earning interest on the interest I earned in the first year. That's called compounding. So this is what I start my next year with. So I'm earning interest the next year on $70 more than I did the year before. So you can see what happens here as you continue on. So the next year I start with this much, and again I do 1.07, and that time that's going to now equal, so times 1.07 again, $1,225, $1,225.04. Now, you should probably use your calculator and do a couple of these with you. So look what's happening. What am I doing each time? I'm taking my initial investment, A, I'm multiplying it by some growth factor, B, but look, I'm just doing it the same every year. So I could just do that. Well, watch what I could get right here. What if I had done 1,000 times 1.07? Well, literally what I did was, that's the problem that you see here. Well, look at this, you guys. Couldn't I just write that as 1.07 to the third power? Of course. So I could have done my initial investment of 1,000 and then times 1.07, my growth factor. Actually, 7% is the growth factor. The 1 just takes care of the 1,000. We'll talk about that later. And how many times did I do it? 3. So if I were just to put this in my calculator and just do that, the way you would write that, the best way to do this in your calculator is take the 1.07, raise it to the third, hit enter, and then multiply by the 1,000. And if you do that, you will see, raised up to the third, I'm just doing it on my calculator here, I hit enter, and then multiply by 1,000. Let me see that. 1.07 raised up to the third power, I hit enter, and then I simply multiply that by the initial investment of 1,000. And notice, what do you get? You get what we got right here. You still get 1,225.04. So this is just but here it is. There's A, B to the X. See that? Well, you might say, oh, big deal, Pat. What the hell? Who cares? Well, I'll show you one thing that you can care about. And this is how come rich people stay rich and we all stay poor. All it takes in your family is one person to strike it really rich, and everyone should be rich for the rest of their generations. And it's because of the time value of money and this idea of compounding. So watch this. Let's just say you had a rich uncle. And when you were born, he said, well, I don't want little Johnny to have to worry about retirement or any of that crap. I want him to, at 50 years old, I want him to be able to retire and do whatever he wants without worrying about the government taking care of him. So to that end, I'm going to say, look, he was just born. I'm a rich guy. I'm going to put, let's say, $50,000 away for little Johnny or little Johnny Weena. Okay? So he's going to take $50,000 on the day you're born. And he's just going to put it in an account. Now, historically, you can usually get about 7%. If you look over the time, the average in the stock market, whatever, is about 7%. Let alone not right now, but whatever. Over the time, 7%. So the growth rate is, like I said before, 1.07. Now, how long he wants you to retire at age, what? 50, so you don't have to work to an old man like me? Look, that means 50 up there. Because every year you average 7%, so 50,000 times 1.07 times 1.07, 50 times. I think you'll be shocked if you figure out what that will equal. I was the first time I saw this. I'm like, holy moly, man. So on this one, I'm going to take 1.07 and raise it to the 50th, and then multiply it by that initial investment of 50,000. Now, don't freak out when you see it. Okay? And now I have to multiply that by 50,000. Yeah, you would have $1,472,851 when you turn 50. And that's just an average investment. You could do a little better or a little worse than that. You think you could survive on that? If you put that away and just live on the interest, right? What can I get on interest on this? What is 7% of this number? Well, let's see. Times 0.07. It's, let's see, 103,000 approximately. It's $99. But look at this value right here. That's just the interest on that, assuming you're getting 7%. Can you live on $103,000 a year? I would think so. But you might be missing the big point here. So little Johnny turns 50 and he just starts taking the interest out of his account. And he lives on his $103,000 year after year after year. But he's not touching any of this amount here called the principal amount. That just stays in there, generating money. So what happens when Johnny dies? Let's say Johnny had 2 or 3 kids. That money splits between those two, so they'd each get about $700,000. And then they would start this process over and over and over again. That's how come rich people stay rich, if they're not stupid. And most of them are not. A lot of them are, I guess, but some of them are not. And if they do this kind of idea, you'll see what happens. It's amazing. So hopefully you guys will kind of understand that. And I would like you to try a few little problems in the book. And I'll talk more about compounding interest tomorrow, if I can figure out how to do it from my phone. But I'd like you to try on page 469. So let me do this. 469 in the text. I'd like you to try numbers 13 through 33. Do the odd ones so you can check your answers, okay, guys? And then I'll answer any more questions. Please keep emailing me with those questions. I didn't get any emails over the weekend, or maybe you guys took the weekend off, but if you're still struggling with anything from the chapter 7, whatever, or any of this stuff, please email me and I'll answer your questions for you, okay? All right, guys, well, I'm still missing you. God, I hope we get to see each other again before the end of the year. Otherwise, I won't get to say goodbye. But hey, it is what it is, guys. We got to keep on doing it. So hang in there, and we'll talk to you soon.